Have you ever used an AI and just thought, wow, it actually gets what I mean? Well, today we're going to pull back the curtain on Milvus, the open-source data brain that's making so much of that possible. This is the secret sauce behind AI that feels less like a calculator and more like a conversation.
So, let's just start with a fundamental question. How in the world do you get a computer to search for something that doesn't have a specific name? You know, something with a certain feeling, an atmosphere, a vibe. For a normal search engine, that is a huge, huge problem. I mean, just think about it. What if you could find a movie just by describing the kind of story you're in the mood for? Or find a song just by describing its energy? That is the exact gap we're talking about here. The massive canyon between how our human brains think and how computers have always been taught to search.
And that gap, well, it has a name. We can call it the keyword trap. For decades, pretty much our entire digital world has been built around one simple rule. Find the exact words I type. But that's just not how we think, is it?
And this slide just nails the difference. On one side, you've got your classic keyword search. You type in fluffy animal, and it obediently looks for those two exact words. But on the other side, you have semantic search. You type fluffy animal, and it understands the idea you're getting at. You know, the concept of a cute, furry creature. It's the difference between matching letters and matching meaning. So the billion-dollar question is, how do we teach a computer to finally understand what we mean? Well, it turns out the answer is to teach it a totally new language, and this language is spoken entirely in numbers.
And that's done through a really cool process called vector embedding. You can think of it like a universal translator for everything. It takes any kind of unstructured data, a sentence, a photo, a piece of audio, and it distills its essence, its core meaning, into a long list of numbers. And that list of numbers, that's called a vector. Here's a super simple look at how it works. Step 1, you start with your idea. In this case, the phrase, a fluffy animal. Step 2, you feed that phrase into a special AI, an embedding model. And then step 3, bam, out comes a vector. It's like a numerical fingerprint that perfectly represents the idea of a fluffy animal. Now the computer has something it can actually compare and contrast.
Okay, so you've got these numerical fingerprints, these vectors, but what happens when you have millions of them? Or billions? Where do you put them all? And how on earth do you search through them in the blink of an eye? Well, that's exactly where Milvus enters the picture.
To put it simply, Milvus is a database that was built from the ground up for this new kind of data. It's not designed to store tables of names and phone numbers. Nope, it's designed to store meaning. Its entire job is to take in all these vectors, organize them, and find the ones that are most similar to your search query, and to do it incredibly fast. And you should know, Milvus has a serious pedigree. It was first developed by a company called Zilliz, but it's a completely open-source project. And it's not just any project, it's a graduated project of the Linux Foundation's AI and data arm. And trust me, in the tech world, that's a massive stamp of approval. It means it's legit.
And this isn't some new, untested thing that just popped up. Development kicked off way back in 2017, and by 2022, they'd released a major 2.0 version, totally re-architected to be cloud-native and ready for the massive scale of modern AI. So yeah, it's mature, it's robust, and it is absolutely built for the future.
So what is the big deal? What makes Milvus so special under the hood? Let's talk about its superpowers. The key features that make it the go-to choice for so many people building these next-generation AI apps.
First things first, it's all about scale. We're not talking about a small database for your weekend project here. Milvus is engineered to handle billions of vectors. That is a truly massive, enterprise-level scale that most databases just can't touch.
And it pulls this off with some really clever engineering. Its architecture actually separates the computing part from the storage part, so you can scale each one up independently as you need it. It also taps into NVIDIA GPUs to make searches up to 10 times faster, and it can ingest new data in real time, so your search results are always up to date.
Now this is really cool. Milvus also supports something called hybrid search, which is kind of genius. It lets you combine the power of that semantic search we talked about, using what are called dense vectors, with the old-school precision of keyword search. So you really get the best of both worlds. It can find things that are conceptually similar, and it can also match specific must-have keywords if you need them.
And what's really crucial is that Milvus doesn't live on an island. It plays nice with the entire AI ecosystem. We're talking deep integrations with all the big AI frameworks like LangChain and Llama Index, the big LLM providers like OpenAI, and of course hardware from NVIDIA. It's a real team player.
Okay, enough with the theory, right? Let's make this real. Let's see how this all actually works in the wild. We're going to walk through a simple, real-world example right from the Milvus tutorials, building a movie recommendation system.
So this is our search query. This is what the user types in. And notice, we're not asking for a specific title or an actor. We are literally just describing a concept, a vibe. I want to watch a movie about a fluffy animal.
So here's how it happens behind the scenes. Step 1, you load your data. In this case, it's over 8,000 movie descriptions. Step 2, you generate embeddings, turning every single one of those descriptions into a numerical vector. Step 3, you insert all of those vectors into Milvus. And step 4, the fun part, you search. You give Milvus the vector for our fluffy animal query and just ask it to find the closest matches. You can even add filters, like saying, only show me movies rated PG.
And check out the top results. Number 1, The Adventures of Tintin. Makes perfect sense, right? Because of the very fluffy dog Snowy. Then you have hedgehogs, another obvious match. But what's really fascinating to me is that it pulls up Osmosis Jones. The system is picking up on this abstract conceptual link to animated non-human characters. It didn't just find keywords, it genuinely understood what we were asking for.
So you can see how this one little example really opens up a huge door, right? This is so much bigger than just finding movies. This technology is fundamentally changing the way we interact with all kinds of information.
And this right here is why this stuff matters so much. This is the engine behind what's called Retrieval-Augmented Generation, or RAG. That's the tech that makes chatbots like ChatGPT so much smarter by letting them look up facts instead of just making things up. But it goes way beyond that. It allows you to search across images, audio, and text all at once. It's being used in drug discovery, biomedical research, and it's completely changing online shopping.
So, if you remember one thing from all of this, let it be this. Vector databases like Milvus don't just find data, they understand it. They represent a true paradigm shift. We are moving from a world of just finding data to a world of actually understanding it. We're finally giving our computers the ability to grasp meaning and context at a massive scale.
And that really leaves us with one last kind of mind-blowing thought to chew on. In a world where anything can be searched not by what it's called, but by what it is, what will you look for? The possibilities are, well, they're pretty much limitless.